So we're on to section 5, and we're going to be looking at aldehydes and ketones finally. So we're looking at some carbonyl groups. And the things that we're going to be looking at here is in this checkbox like this. So what we're looking at is the aldehydes and ketones, but more specifically the oxidation and reduction of them. You can see there that there's 5 reactions that you need to fill out. It's not as much as it sounds, I promise. These are all essentially the exact same. They just have different conditions. So you can see where that's going. And then you've got reduction of aldehyde to primary and a reduction of an aldehyde to secondary. That doesn't make sense now that I've said it out loud. I think that is a ketone. And it is a typo in the booklet that I've noticed just now. So I'll get rid of that. And that is a ketone. There we go. So I mentioned at the start that, the booklet, I've only made it once. I've not proofread it yet, so we're going to have to fix those things up. But now I've seen that, I can just change it. I'm going to keep the video because otherwise it's going to take me forever. So we've got section 5, detailed definition again. So I want you to go into a little bit of information about what aldehydes and ketones are. So the differences between the two of them and the fact that they contain the carbonyl group. But not much else after that. I know it says a detailed definition, but if I say keep it short, you'll give me 3 words. So give me a short paragraph around this about aldehydes and ketones with a reference as always. Then we're going to look at 3 reactions. The slight difference here is that we have different conditions. So we have an oxidation of a aldehyde using acidified dichromate, Tollens reagent, and Benedict's or failings. I don't mind which one you talk about. I think Benedict's is easier, so I'll talk about that one. And then finally, we're going to go down to the reduction of an aldehyde and a ketone. You can see there the mistake I made before. Detailed explanation. How do they get reduced? Explain that. Again, a few sentences with a reference. Chem Guide has all the information that you need. Reduction of aldehyde to a primary alcohol and reduction of a ketone to a secondary alcohol. Again, you need to make sure that everything that you draw has been drawn correctly and named correctly. They need to match. And any solvents and conditions have been stated and they're correct as well. Again, referencing Chem Guide, fantastic place for it. I'd go straight to that. Now for aldehyde and ketone, I'm just going to go over very brief information of what the differences are so that when you're reading and researching this information, it matches up to what I'm looking at. Now the key feature of an aldehyde is this hydrogen right there. The way that I tend to remember it is that aldehyde has a carbonyl at the end of the carbon chain. That hydrogen is indicative of that. Some skeletal drawings don't have it. That hydrogen is really, really important. It means it's easily oxidized. It can be a little bit more reactive. Ketones, however, they are in the middle of that carbon chain and they have a carbonyl right there. They're less reactive, they're much harder to oxidize, so we're not going to see any oxidation reactions with ketones in this assignment, but we are going to see a reduction of it. One thing I wanted to talk about briefly is these 2 symbols here that you're going to see quite a lot. These square brackets typically in chemistry just means concentration of, but in the context of the O and the H, this means an unspecified oxidizing agent, and this means an unspecified reducing agent. Now, I know I've said they're unspecified, but part of your conditions is to specify them. So you can leave these symbols in your equations, I don't mind that, but then in your reaction conditions, either above or below, around that arrow, you're going to tell me what those conditions are for that particular reaction. And I think that's the easiest way of going about it. So just remember, for aldehydes, they're at the end and they have this hydrogen here. And then for ketones, they're going to be in the middle. They're named quite similarly, they're named quite easily, not similarly. There's nothing similar about them. Aldehydes is going to end in anal, A-N-A-L. And then ketones is going to end in one, O-N-E, 1, essentially. But I'll talk about nomenclature when we go through the examples. So let's go down. And this is the example I gave you before. Now you can see here, like I said at the start, that the reaction's the exact same, the conditions are different. So the product that you make is going to be the same for each one. Now, some of you might just copy and paste the same reaction over and over again. I'm not the biggest fan of that. I would just do maybe 2 carbon, 3 carbon, 4 carbon example, 1 with acidified dichromate, 1 with Tollens, 1 with Benedict's. That might be an easier way of doing it. I just noticed a small mistake. And then you're going to have the conditions in this box here. You can see here that I've done little squiggly lines. That just means I've got 1 for dichromate, 1 for Tollens, and 1 for Benedict's. And I think the best way of us displaying this information, remember, it's a handbook, it's supposed to be educational. The easiest way of explaining the differences between these three reagents is to have an image. An image will show you loads of the differences there, and they tend to have different color changes. Have a look into that. You've actually all used Tollens reagent before. It's our silver mirror, so you can actually have an idea of what that looks like. But for the other two, have a look at the before and the after of what it looks like when it's not been oxidized, and then what it looks like after it's been oxidized. And you can have that written up in your assignment as well. So you can have a look at that. And I'll give you an idea of putting an image with each of the reactions just to make it look a little bit clearer, a little bit easier to digest. Next thing we're going to look for is down here where we have our reductions. I've actually given you the balanced equation, so I'm just asking you to look for the conditions. I'm not going to tell you what those conditions are. They're really, really easy to find online. Just make sure you're looking for them. So we're going to go from an aldehyde to a primary alcohol, and then a ketone to a secondary alcohol. Again, when you're naming this, give me any form of aldehyde, and then make sure that you're naming that primary alcohol as a product. And then for the ketone, you're going to give me some carbon chain with the ketone. Remember, the lowest carbon chain a ketone can have is 3. So it has to have more than 3 carbons. If it doesn't, it won't work. And then over here, you're going to have a secondary. And wherever your carbonyl is on your ketone, that's where the OH group will also be. So make sure you've got that in there as well. The actual mechanism for this, again, you don't need to know, but we are adding 2 hydrogens to the first one, 2 hydrogens to the second one. But have a look at that. Now for naming them, remember aldehydes is a stem and then anal, ketone is a stem and then -one, and then alcohol is a stem and then -ol. Really straightforward examples. Hopefully you should find this a little bit easier. Again, keep these to a page, make sure your structure is really, really clear, it's easy to follow, and double check all of your reactions. Remember, ChemGuide is the best place for this, so double check your reactions in ChemGuide. But keep it up, guys.